Hello, welcome to Algebra 2 Common Core. Today we're going to explore some linear modeling problems as we look at some application problems. Exercise number 1 says that Dan has been driving away from New York City at a constant speed of 58 miles per hour. We know that he started 45 miles away. In part A, we want to write a linear function that gives Dan's distance d from New York City as a function of the number of hours he has been driving. So you'll notice that we are going to use the variables d for distance and h for number of hours that he has been driving. We are given some important information in this problem, so we want to go back and look at that. We see that his constant speed is equal to 58 miles per hour. We know that this represents a rate, so since this represents a rate, that tells us that this is going to be the slope for our linear function. We also know his starting point. Since he started at 45 miles away, that's going to represent the y-intercept for this problem. So we're going to use our slope-intercept form of the equation of a line, which you should recall as y equals mx plus b. But in this example, we're going to convert to the variable d for distance and h for hours. Now, since the h is our independent variable, we're going to replace x in the equation with h. D, the distance that he's driven, is dependent on how many hours that he's been driving for, so D will replace the y in our equation. So substituting those values in, we have that D is equal to the slope, which in this case is 58, times the independent variable, which is h, plus the y-intercept, which we know to be 45. So that gives us a linear function representing the distance. Now in part B, we have some information that Dan's destination is 270 miles away from New York City. We want to algebraically determine how long it's going to take Dan to reach his destination. So that tells us that he wants to travel 270 miles. So we're going to replace the d with 270 miles. We still have the unknown h in our equation, so that tells me that I want to solve this equation for the variable h. I'm going to subtract 45 from both sides of the equation to isolate the h. This tells me that I have 225 is equal to 58 times h. And to solve for h, we're going to divide both sides by 58. Now use your calculator to do that division. And I got on my calculator that h is equal to 3.9 hours. Remember that we wanted to round it to the nearest tenth of an hour. In exercise number 2, we're looking at Ellen and her cell phone plan. She has a fixed cost, but she also has a charge per call that she makes. So each call costs her 15 cents. She has some information that it took a cost of $12.80 to make 52 calls. So we know that calls is representing our independent variable. We're going to call that C. And we know that she, in this case, has made 52 calls. We also know that the cost, which we're going to use for the amount that she has to pay, we're going to use the variable P, and we see that she had to pay $12.80. This time, we're going to have to use the point-slope equation of the line so that we can make the equation. Remember that the point-slope equation of a line is y minus y1 equals m times x minus x1. So for this equation, we're going to replace the p, the amount that she's paying, instead of y. We're going to subtract that value, so P minus 1280 is equal to the slope. Now the slope is really the charge for each call. So we're going to use the 15 cents as our slope. So 15 cents multiplied by the x, the independent variable, is now going to be the number of calls. So C minus 52 calls. This is the equation in point slope form. When we get to part B, it says how much is Ellen's fixed cost. In other words, how much would she have to pay for making 0 phone calls? So we want to solve for the P when C is equal to 0. I think it might be easier to convert this equation over to slope-intercept form. So I'm going to take my equation, P minus 1280, and I'm going to distribute the 15 cents, so 0.15 times C. When I use my calculator to multiply 15 cents times 52, I'm getting a total of $7.80. Let's isolate the P, so I'm going to add 1280 to both sides of the equation. And I see that I'm getting the new equation, P is equal to 15 cents times C plus $5. This equation is now in slope-intercept form. That'll be more useful to us because we know that the number of calls is equal to 0. So if the number of calls is equal to 0, we can substitute that in for C. So 0.15 times 0 plus $5. That shows us that the amount that she's going to have to pay for making 0 calls will be $5. That answer actually is the y-intercept of my function. That makes sense because my independent variable is equal to 0, and my dependent variable, P, turns out to be $5. In exercise 3, we have several functions that we're going to be looking at. We're talking about a factory that produces widgets. There's a cost to produce the widgets, and there's also a revenue that we're going to get by selling the widgets. A widget is just a generic item that a factory can produce. This problem is going to require your graphing calculator, so if you don't have your calculator in front of you, please pause the video and go get your calculator and come back. So for the first part, we want to graph both of these functions using our graphing calculator. We're going to want to make a table of values. We're going to want to change the window on our graphing calculator. So for the first part, we're going to look, I'm going to do 2 different colors for my function. So let's start with the blue function for cost. The cost is equal to 0.18W plus 20.64. So for this graph, I know that my y-intercept is going to be 20.64. And again, you can enter that equation in y1 in your graphing calculator and then make a table of values. So we've got number of widgets and also the cost. When W is equal to 0, we know that the cost is $20.64. Now go ahead and make some more, put some more values into your calculator. Maybe make your table count by something like hundreds so that you can get all the way up to making 500 widgets. So pause the video while you make your table of values. Come back and check with mine. Check your table of values with mine for the number of widgets and the cost to produce those widgets. And then go ahead and plot that function on the axes that's given. Notice that on the x-axis, on the w-axis, I've counted over by hundreds all the way up to 500 widgets. And then on the y-axis, on the vertical axis, we're counting money, so that's going to be in terms of dollars. and I've gone from 0 up to 150, counting by 50s. Now when you finish that, let's take a look at the second function, which is our revenue function. This one I'm going to graph in red. So I want to make a table of values. I've got my W and the R value. At 0, I see that I'm going to have a revenue of 0. That makes sense because I won't make any money if I haven't made any widgets. Pause the video, make your table of values, and plot this function as well. Check your table of values with mine for the revenue. You'll see that I've also plotted this function and that this function goes through the origin because when I've made 0 widgets, I have 0 revenue. Now in part B, we're going to use our calculator again and a new command that we haven't seen yet. We're going to be using the intersect command to find out how many widgets must be produced so that the cost is equal to the revenue. You'll notice that on my graph, this should be where the two functions intersect each other. I'm not sure if I've exactly hit that spot on my graph that I've drawn, but I can see that better on my graphing calculator. So, hit the graph key on your calculator. If you haven't adjusted your window already, we're going to want to make sure that we adjust our window on our graphing calculator. So you're going to go to the window key. When you press that key, we want to make our window on our calculator match what I've got on my piece of paper. So my X min value should be 0, my X max value should be 500, and I'm counting on the X axis, so I call that the X scale. I'm counting by 100s. My Y min is also going to be 0. My Y max I have going up to 150, and I'm going to use a Y scale of 50. So we're counting by 50s on the y-axis. Now press graph again, and you should see the two functions, and we should see that they intersect with each other. To use the intersect command, I'm going to write down what keys I've pressed. We're going to press the second key, which is the blue key, and then we're going to press the one that says trace. When we press the second trace key, that's going to put us into a menu that is called the Calculate menu. For the Calculate menu, we are going to select option number 5. Option number 5 is Intersect. We want to know where these two functions intersect. Hopefully you've used this before, but if you haven't, when I select number 5, Intersect, it's going to give me a cursor on my screen. You can use the right and left arrows to move the cursor. You'll be moving along your first function first of all. So I'm going to make that cursor go close to the point of intersection, and I'm going to press the Enter key. It's going to then ask me to move the cursor on the second curve also to the point of intersection. Well, since I'm really close to the point of intersection already, I'm going to press Enter again. And then it's going to ask me for a guess. I'm going to press Enter a third time. When I do that, I see on the bottom of my screen that it has told me that the intersection point is 258.67.08. If you have any trouble with that, try repeating the steps again, and if you're still struggling, please see me and bring your calculator so that we can go over it in person. This answer tells me that I need to make 258 widgets in order for the cost to equal the revenue. Now in part C, we're going to combine these two functions by defining a new function called the profit. So the profit function is just going to be the revenue minus the cost. So taking our two equations, we're going to say the profit is equal to the revenue, 0.26W, minus the cost. Now, since the cost has more than one term, I'm going to enclose it in parentheses. So 0.18W plus 2064. I'm going to simplify this equation to make it easier to work with, so I'm going to subtract 0.26W minus 0.18W, and that gives me 0.08W. Take the negative and distribute that also through the parentheses, so it's going to be minus 20.64. So this equation becomes our profit equation that we're going to use in the last part of this problem. Now in part D, we're going to go back to our graphing calculator, but this time we're going to graph the profit function that we've just created. So remember that our profit equation is P is equal to 0.08W minus 20.64. So we're going to go to our calculator, and in our y equals, we're going to clear out both of the original equations, and in y1 we should enter this new profit equation. Notice that I've set up my graph so that the interval on the w-axis, which is the horizontal axis, goes from 0 to 1,000, and I'm going to use my table of values to decide how much I need to go on the vertical axis. So take a minute and pause the video, enter this equation into your function, and then go ahead and look at the table of values all the way up to w equals 1,000. Again, when you're looking at your table, you can make your table maybe go by probably 100 on the horizontal axis. So when I entered this equation into my y equals, and I made a table of values, again counting by about 100, I see that at 0 widgets, I'm actually having a loss. I don't get a profit because it's a negative 20.64. If I make 1,000 widgets, then my profit turns out to be $59.36. So I'm going to set up my y-axis, my vertical axis, which is representing my profit, and I've counted by tens going all the way up to 70 so that I can accommodate that profit of $59.36. So take a minute and again adjust your window on your graphing calculator. So this time I'm going to make my x-min still be 0. My x-max is going to go up to 1,000, and I'm still counting by a scale of 100s. For the y-min, this time I need to consider some negative values. So I'm going to say let's make our y-min be negative 30. Let's make our y-max go all the way up to 70. And we're going to make our scale on the y-axis go by tens. So adjust your calculator window, hit graph, and then go ahead and graph this function. Pause the video while you do that. Check your graph with mine. We also want to label the x and y intercepts of this line on the graph. So you'll see that my y-intercept was the point where we made 0 widgets. So that again is negative 20.64. And that's this point that's right here. For the x-intercept, that's going to be where I have 0 profit. Well, 0 profit is of course going to be where my cost is equal to my revenue. Back in part B, we learned that the cost was going to be equal to the revenue whenever we made 258 widgets. So you'll see that my graph does cross the w-axis, and I've labeled that at 258. And fortunately, mine looks pretty accurate. Let's go on to part E. For part E, it says what's the minimum number of widgets that must be sold in order for the profit to reach at least $40. So if I want to reach at least $40, I'm going to go ahead and graph on my graph. Let's make this a different color. So I'm going to do y2 is equal to 40. That happens to be a constant function, so it's going to be a horizontal line going through 40, and it looks something like this. Now the next part is to figure out where that 40 intersects with my profit equation. So I'm going to again use my graphing calculator. On the graphing calculator, now that I've graphed both functions, I'm going to press second, calculate, and do the option in the calculate menu that says intersect. Use your right and left arrows to make your cursor go close to the point of intersection. Remember that we end up pressing enter 3 times, and we find out that the intersection point turns out to be W is equal to 758 widgets. Now I'd like to verify that algebraically in just a second as well, but let's label this on our graph. So this point right here is where I have made 758 widgets. Again, it's pretty accurate on my graph. Now let's check that answer by solving this equation algebraically. So we want to know when 0.08W minus 20.64 is equal to 40. So we want to add 20.64 to both sides of the equation. We now have 0.08W is equal to 60.64. Dividing both sides of the equation by 0.08, I see that I get W is equal to 758 widgets, which of course matched with the answer on my graph. Now, as long as I make at least 758 widgets, that means that my profit will be at least $40. If I make more than 758 widgets, then I'll have a profit of more than $40. Thanks very much. Hopefully you got a lot of practice today with your graphing calculator. If you have any questions, please see me during activity period. Bye-bye.